Hello everyone. In this video we will discuss merge sort, one of the interesting sorting algorithms, which is a divide and conquer algorithm, which uses recursion as well. We will see in a minute. Okay, so when we say divide and conquer, this is a technique that is used by many other algorithms as well. So let's say we have an array which is let me see, which has 7 elements. Okay, so these are, as you can see, not sorted, and we are going to sort this by using merge sort. First of all, as you can see, we have divide here. Okay, we will try to implement this divide technique. In order to divide this array into 2, we will use this formula all the time. So first of all, we will find the middle index. The middle index is the left index plus right index divided by 2, which will be roughly the middle element, the index of the middle element. Okay, so for instance, in our case, left is 0, right? 1, 2, 3, 4, 5, 6. Okay, so the index of left, so left index is 0 and right index is 6 in our case. And if you try to find out what is the middle index, it's going to give us 3. Okay, so this will be our middle element. Why? Because 0, 1, 2, 3. So this is the middle element. Okay. Now, when we divide, we have to consider it from the very beginning, whether we will put this middle element to the left let's say array, or to the right. So if we decide that we will include it in the left sub array, it's nice, but we have to do the same for all the rest of the divisions. Okay, so let's see what comes next. And here, as we can see, if we divide it into 2 by using this, we will have 23, 42, 50, negative 3, and the rest in the next array. But keep in mind that we are not, when we get to the programming, to the coding, we will not physically divide them. We will still be using the same array, okay, the same original array, but instead we will play with the indexes in order to imitate the division of the arrays. Okay, so this is my first division into 2. Now, if we follow the same calculation, same formula, we will have, so this is 0, if you remember, and this was index 3. Okay, so the middle of this is 0 plus 3 divided by 2, which will give us 1. So 0, 1, this is my middle index. Okay, so this is my middle. And what about here? It is left is 4 and right is 6, and it will give us 5. So this is the middle. So when I divide it into 2, I will have 2 of these elements to the left subarray of this array, and this 100 to the right subarray. So let's see the further division. So as you can see, I have 2, 2, 2, and 1. So in total, we have 4 subarrays. Okay. Now I will not draw the following, and if I separate it, like divide it into 2 once more, I will have this, I will have this, I will have these divisions, and this one will not be divided because we have only 1. So once we have only a single element, we should stop. All right. So we should not go further dividing into 2. Okay. So in the last level of, as you saw, it was recursion. Okay, as the last recursive call, or as the last step of the recursion, we have this single I'd say element. So as you can see, there is no way to separate or divide this into 2, and neither others. Okay, so this is the first part of the merge sort, the divide part. Okay, so far what we have been doing, starting from here, it was divide, divide, divide until the time when we cannot divide anymore. Okay, so as you can see, this is a recursion, and let's try to write the code for the first part, for this recursive part, and then we will switch to the next part, which is the conquer part. Okay, so let's get to the code here. Okay, in order not to lose much time, I already declared and or defined some of the functions, and you will see what are those before we start. Okay, so print range is a function to print my array, and it's not an ordinary print array function, because so far we have been using some print array functions, and those were taking as input the array itself and the size of the array, and were printing starting from 0 until the last very last element. But here it's kind of different. Why? Because here I am providing a range as well, so that we can print several parts of the array, just like we were dividing it here. As I mentioned before, we will not physically divide this array into 2, but instead we will try to, I'd say, imitate the fact that we were dividing. Okay, so this is print range, and how this print range works, it's very simple. It just first prints that I'm printing the range from left to right. Okay, and it starts printing just by using an ordinary repetition. Okay, so I don't think this is going to be hard. That's why you can pause the video and you can copy and paste this if you want, and I will hide this now. Okay, so this is the first function, which is a straightforward one. Now this is msort function, which is the one that we will implement now. This is divide and conquer. And let me also mention that it's a recursive function. Okay, now let me try to copy. Anyways, I have already copied. Okay, so this is the function that we will try to define now. Okay, now as all the other recursive functions, what do we need? We need a base case, or maybe one or more base cases, and we need some, again, one or more inductive steps. Okay, so let's see what is the base case for our function. So base case, if you remember, was the case where we stop calling ourselves, because recursive function is a function that might call itself, and somewhere along the line we have to stop and start returning, right? So that case is called the base case. And if you remember here, when do we stop calling ourselves? When do we stop dividing further and further? It is when we find a single element. So it's when we have the left, so this is left, right index, and this is the right index. So when the left index and right index are the same, it means this is the last step that we should perform some operation. And when already this left index and right index change their places, so when the right index is less than left index, so that means it's not a valid range anymore. So that's why we have to stop the operation. Okay, so as we said, if the left is already, let's say, equal and greater than right, actually, if we subtract 1 by 1 each time. Okay, anyway, so in any case, I will use this greater or equal. So if left is already greater or equal than right, that means we should not go further, means let's just return. And as this return type of this function is void, we can return just without passing any value back to the caller. Okay, so this is the base case. In our case, now we have only one base case because there is only one condition when we stop calling ourselves. For instance, here you see we have 100. As I copied and pasted it here, it was just to explain, but in fact we don't go further after this. Okay, so after this we don't go further. It was just for the sake of explanation. Okay, so this was the base case. Now let's see the inductive step. What is the inductive step? Inductive step is how we go to the next step. Okay, how we perform the operation further on the next step. Or imagine if we have one instance, how we can calculate the other instance based on this instance. Okay, or if we put it in another words, if we have a complex problem, having the smaller problems or subset of these problems already calculated or computed, how we can compute the complex one. Okay, so we said we need to divide further, right? So in order to divide, we have to perform this operation. So I will take an integer middle index, which is going to be equal to left. In our case, it's left, you see. Let me put left index in order not to confuse it with the elements. So it's index, and it is index. Okay, so this is it, and left index plus right index divided by 2. Okay, so this is my middle index, and when I perform inductive step can be in two directions. You see, I can go with the left hand side and I can go with the right hand side, or left subarray or right subarray. So it's actually doesn't matter much which one to start with. So I will start with the left one. So what should I do? I should call msort function again on the same array, but this time sending new range for the further operation step, let's say. So for the next step, so for this, let me put it here. Okay, for here, the left index will stay the same, but look, the right index becomes the middle index. So here it will be left index and mid index. Okay, so we will perform operation on this range, inductive step 1. Okay, and what about inductive step 2? So we will perform the same operation on the right sub-array, or right half of the array. It's msort. The physical array itself will stay the same, and we should start with, you see, it was m-index, so we should start with the right, the next element of the middle index, so which is mid idx plus 1, and we have right index, which will stay the same. So it's inductive step 2. Okay, so this is where we keep dividing until we receive, we come to the base case, which is the case where we cannot divide into 2 anymore. Okay, so this is basically it in the division part, in the divide phase of the merge sort. Okay, the next one will be merge the parts, let's say, which we will call later on this function, and we will explore it before writing the code as well. Okay, so let's try to test this function. And as I always suggest or recommend, is that please do test your functions as soon as you finish, because otherwise you will end up having a huge code base which is not tested at all, and you might have problems, and it might get really hard to fix those problems. Okay, so let's try to test it. Okay, so I will get back to the main function. Here, as you can see, I have created an array. The name of this array is vector, which has 7 elements. Those are the elements from the presentation. So let's first, I have tested already, but let's test the print a range function. So compile. Okay, and okay, so printing range 0, 3, as I provided here, and printing range 4, 6, as I provided in the second function call. Okay, and it prints it right. Okay, and now let's try to see msort function. Okay, so if we take a look at msort function, we will see that here we don't print anything, so probably it will not print anything. Let me comment this too. Okay, but how we can know at least it doesn't go wrong is that if it doesn't enter in an infinite recursive calls, it means it will start returning in the right place. So let's try to see. Okay, so it does execute, means there is no error so far. Now, in order to visualize how it calls and what it does each time, I will put this print range function call here before the return statement, before the base case. Sorry, I will put it here just to see. Okay, so I should provide the array, I should provide the left index, and I should provide the right index. Okay, and by the way, these are okay. I modified the variable names as well in order not to confuse with the elements with the indexes. Okay, so now I will try to print this. Okay, so let's see, compile and run. So first I call this sort function for 0, 6 range, so entire array. So that's why it will call the print range function with the same range. So as you can see, this is my entire array. So the second call is, as you can see, with 0, 3 range, which is the left half of my array. And then this one, in its turn, will call its right, and then it will call its right. You see this one? So if we get back to here, how this one is performed is that first I start with this array, and then it will divide and take its left. Why? Because we call first this inductive step. Okay, we go like, let me say it is left half, and this one is right half. Okay, so since we call the same sort function for the left half, so it like it keeps calling the left half until you see there is 0, 0. As you can see, they're already the same. Okay, and it will not do anything, and it will return from 23. And what about here? Once it gets back to this, okay, it will go with the right side, which is 42. Okay, and once this array is done entirely, it will return to the previous one, which had the right part left already, and it will stick with the right part. And again, from 50 and -3, it will go with the left and the right, and so on and so forth. Okay. So this is a kind of simulation of the function calls by just looking at this the printed values. Okay. All right. So this is we suppose we achieved this division phase of this merge sort. Okay. Now the next phase is the conquer or the merge part. Okay. So far we have just been dividing it into two. Now we will start returning, but while returning we will merge and return. Okay. Now let's look at the merge part. Now, this is the values that we have in the last level, right? Now, what should we do? We should merge these two together, and these two together, and this one is single, so that's why it will just keep waiting. So when we merge these two, what we have here is that we will take a look at these two values. Which one should come first? So here, 23 should come first. So 23 will be coming here, and then 42 will be coming here. What about a pair of these two? -3 should come before 50. So -3 will come first, and 50 will come second. And similarly, 23 should come before the 45, and 100 keeps waiting. And as you can see, 23, 42, -3, 50. So pairwise sorted, let's say. Okay. Now, what about the next level? In the next level, what we will have length 2 arrays that should be merged. Now, let's look at the way how we can merge these two arrays. So we should start with the first index of both, okay, and compare which one should come first. So apparently, -3 is the smallest, so -3 will come here. Now, what about the action that I should be doing after this? I will point to the next value. Why? Because this one is already taken, and this one is still waiting. So now I will compare 50 with this one. So which one is the smallest? This one apparently is the smallest. So 23 will be placed as the second element. Now, as soon as I selected 23, I should increment this pointer. It's not a pointer; it's it's an integer which stores the current index. Okay. So what about 42 and 50? So apparently 42 will be selected. Okay, and since this one, after selecting this, it should be pointing somewhere here, and there is no element here. Okay, we should stop reading the left array, and we should continue looking at the right array. If we still have something that should be put here, as you can see, we have only one element which is left. We should put it here. Okay, and as you can see, after doing that, we will have this. There is no element here. And that's it. That's the end of this. Is basically what merge function will do. Okay, so let's see. We will have here -3, 23, 42, and 50, and similarly here 23, 45. They are in this in their correct order, and 100 will come and join the rest. Okay. Now the last one, -3, is in its nice place, and 23 will come here. And what about this 23 and this 23? So after this one will come here, the pointer, the indicator, let's say, will point to this 42, and 23 is less than 42, so that's why 23 will be put here. And so on and so forth. So 42, 45 selected from this array, 50 and 100. Okay, so this is basically how we perform the merge operation. So I will take it back to here, and this is the line by line implementation that we should be doing in the code level. Okay, so let's get to the code again. Okay, so this is my merge function, and here I still need this middle index value. Actually, if you look at the resources that are available in the internet in some books, you might also find something like this into middle index. Okay, so this is also possible because in merge sort you already calculated the middle index, so this one. So you can also send it to the merge function in order to avoid this calculation again. But I will keep it simple. You can do this, but I will keep it simple, and I will put it here. So mid idx, which is of type integer, is equal to And by the way, since they are both integers, divided by 2 will make an integer division, and it will give us an integer value. Okay. So once we have this middle index, which is, for instance, here, which is, where is that? This one. Okay. Now I should I should be okay. I will create two temporary arrays, because of the fact that I will be modifying the original array. Okay, since I will be modifying the original array, I might end up losing some information, some data. So that's why I will copy the range, okay, into 2. So this one, let me see, this one is the right array, and this one is the left array, right? So I should be copying these two into temporary arrays. And in order to do that, first let me define the sizes of both arrays. So first of all, let me say left array size. Okay, this is starting from left index until and including middle index, right? So it will be equal to middle index minus left index plus 1, because the middle element is also included in the left array. And also I will have right array size, which is right index minus middle index. Okay, since middle index is excluded, it will give us the right size. Okay. Now, the thing that we should be doing was that creating two temporary arrays. So tmp left array, okay, of size left array size, and I should be also creating tmp right array size. Okay, so once I have these temporary arrays, now what should I do? I should copy the appropriate elements to the tmp arrays, right? We can, it's cop, not cop, it's copy. So in order to do that, we can just basically create two repetitions here, because we have two arrays. But instead of doing that, I created a function. I defined a function in copy array. And of course, you can use your own function, or you can just basically put a repetition here. Anyways, the repetition is the same for this, or if you put it here, it's up to you. So what it does, I will send the source array, okay, and the source index. So from which index I want to copy the elements of source array, right? And then I should send the destination array. So to what array I will be copying, and starting from which index of the destination array I should be copying, all right? And size is the number of, let me change it to number of elements. Okay, so the number of elements that is supposed to be copied. Okay, so let me see. Here, I should call in copy array. Okay, the source array is what? The source array is my array, right? And from which index I should start copying? let's say we are copying first the left one. So I should start from left index. Okay. And the destination array is temp left, TMP left array. And from which index? Fortunately, it's from 0. And how many? It is a left array size. Okay. So we successfully copied, I hope we successfully copied the left part of this array. And what about the right part? So we should be copying array starting from middle index plus 1, right? Then we should, okay, TMP right, again from 0, because we start to fill this left and right arrays from the very first index, and right array size. Okay, so I suppose we are already done with the copy part. Copy part means that now I have two separate arrays, which the first one holds the information about the left half of my array, and the second one contains the elements of the right half. Okay, so the next part we should be doing is merge itself. Okay, so far we were trying to prepare some preliminary stuff. Now we will start to merge. Merge means that compare and place the elements into right indexes or indices. Anyways, this is different ways to spell indexes. Okay, so let's see what we should be doing. So here, if you remember, I had one pointer here, actually not of type pointer, but it plays the role of a pointer. It was an index, which will go forward on the left. We have another one which will go forward on the right, and we have another one which will place, the elements in the right in the original array itself. Okay, so we need three indexes, the temporary indexes. So I will name the first one as ARR IDX, which will start from left index. Okay. I will name the second one as TMP left IDX, left ARR IDX, which starts from 0, and TMP right ARR IDX, which will also start from 0. Okay. Now, what is to be done? We need a repetition, as you saw here. We start from the very first one and we go until both this array, this one and this one, both has something to be compared. Okay, so if both of them have some elements, we should be going. So let's say temp left array index is less than left array size, and temp right index is less than right array size. Okay, so this is the condition to compare an element from left array and an element from right array. So let's do the comparisons. If this element from the left is greater than the, let's say smaller than the second one, I should select this one. Otherwise, I should select this one, right? So that means the condition is this: array of, not array of, let's see, temp left array of temp left array index. So if this one is less than TMP right array of TMP right array index. So if this condition holds, means that, let me see, I have some error. Okay, so if this condition satisfies, it means that the left array element should be selected or picked. Okay, so picking an element means that we will take this one and we will assign it to the current position, in the array. Okay, so here. The current position was array index, right? Let's say cur array index. So that means array of cur array index should be equal to the smallest one, which is this. Okay. So if we picked the left element, we should be incrementing this index so that in the next repetition we will play with this one. So TMP array left array index should be incremented. Okay. Now, what about if this was not the smaller one? In that case, we should go with the right, this one, right? So let me copy this. Here we have right array element should be selected, and we should be doing this. Right array of TMP right array index. And since we picked the right arrays element, we should be incrementing this index. Okay. Now both of them will assign something to my array, right? So that means for the next repetition, means that once one iteration is over, it will jump back to the beginning of the repetition. So that means I should also increment current array index. Why? Because in the next iteration, I wanted to pick something for the second element, and then for the third element, okay, and so on and so forth. So let's see this. Okay, so we will test it. I suppose this is the right one. Now, something is still left, and what is that? It is, imagine a case like this. So imagine I have no, not this one. Let's see. 50. Okay, so imagine I have already finished filling everything from left. You see, -3 will come here, 23 will come here, 42 will come here. And the left array is over. Left array is finished. But we still have some elements in the right array. So we should be also considering that one, because this repetition will not consider those cases because we have and here. So both of them should have something to be compared. So here we will, while we will put this condition first. No, yeah. That means right array is finished and left array has some elements left. Okay, so in this case, what should be done is this. I will copy whatever we have in the. Okay, I will copy whatever we have in the left array, because considering the fact that left array was already sorted, because we start with the single elements, and each time we go on to the next level with sorting it. So that means if you are in the third level, you will know for sure that left array and right array from the previous step is already sorted. Okay, so we just put everything here. And what about if we have the vice versa, the other case where left array is finished, but right array has still something to say, to put, to contribute. So that's why I will have this while. And for the condition, I will put this. Sorry, not this. This is the condition. Okay, and here the thing that should be done is this. And don't forget to increment the index here. Okay, so I suppose this is it with the merge sort, merge part of the merge sort. I know it's a little bit longer. I think you can also make it a little bit shorter if you want, but it was not the main purpose of this tutorial. Okay, so this is how we do the merge. Merge means, again, the one that we go back. Okay, so the only thing which is left is to call merge. And when we call merge, we will call merge after, you see, finishing with the like division stuff. So once we are back from divisions, we will, as you saw here, what we did was this: divide, divide. Once we are done, we start merging, right? So divide, 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 and we start merging. So merge, I should be sending the name of the array. I should be sending the left index and right index. Okay, so this is the merge part. Okay, let's see. Right, msort. Okay, will do what it is supposed to do, and then I needed to print a range. Okay, now let me get rid of this print range because it was printing in each recursion, in each recursive call, which I don't need right now. So msort will try to divide, 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 and then start merging. And print a range 0 to 6 will print everything that we have in our array, in the modified array. Okay, because we are sending the address and we are modifying on that function called by reference, if you remember. Let's see. No warnings, no errors. Let's see. Okay, so we have some mistake here. Probably it's because of the indexes. So let me see. Okay, so okay, seems like this is some temp right array, temp right array IDX. So you see, this is why copy and paste when coding is not recommended so much. So let me try this one now. Compile and run. Okay, this is a little bit better, but it's still not correct. So let me see. I have, you see, again, copy and paste. I have the same error here, temp right, temp right. So let's try once more. Okay, it seems like we have the correct answer. -3, 12, 23, 23, 42. Okay, so that's it. That's it. Again, I'm sorry for a long video, but I tried to explain everything that I think should be explained in order to understand merge sort entirely. So this is it. If you will have any questions, please do not hesitate to ask. And that's it. I hope you enjoyed the video, and see you in the next video tutorials. Take care of yourself. Bye bye.